Decomposition reactions. It's the splitting of large molecules into elements or smaller molecules. So if I start with like a big blue-white ball, I can break it down into its parts. So I could break it down into a white ball plus a blue ball. Another way to look at it is if I call that AB, well, when I split it up, I have A plus B. So AB gives us A plus B. So it's when we have one big thing and it splits up into smaller things. So I have a few examples. So water, if I run an electric current through it, it will actually split it up into hydrogen gas plus oxygen gas. Here's another one. Ni3 splits up into N2 and I2. So the nitrogen and the iodine split up. So you have one big thing splits up into two small things. But it doesn't have to split up into just molecules, elements. We have smaller molecules. So if we have this giant thing here, NH4NO3, ammonium nitrate, it splits down to N2O plus water, H2O. So here's an example where we have this giant molecule and it splits up into two smaller molecules. For our fourth example of decomposition, I want to write out a balanced equation. So we're going to start with this one. It says an electric current running through water decomposes into hydrogen and oxygen gas. So electric current, that's actually energy. So in my equation, sometimes we just write the word energy, which means you need to input energy to make this happen. So we have energy running through water, which is H2O. Except we're writing out word equations, so we're going to write water. And we do know water is H2O. And that breaks down into hydrogen and oxygen gas. So hydrogen plus oxygen. All right, so once you have your word equation, now we're going to put in the formulas. Now, there's no formula for energy, so you just rewrite it as energy. Water we know is H2O. And hydrogen gas, that's one of our diatomics. So it is H2, and it's a gas. We put a little G there. Water we know is a liquid, so we should put an L for liquid. And oxygen, that's also a diatomic. So it's O2. It's also a gas. And I knew that because it told me into hydrogen and oxygen gas. So these two are gases. Water I know is a liquid. And it told me I had to put energy in the system. So now we have to look at it and balance it. So we start by just counting. I have 2 hydrogens on this side and 2 hydrogens on that side. So that's okay. Next, when I look at the oxygen, 1 oxygen on the left side, but 2 on the right side. So I need to put a 2 over here so the oxygen's balanced. However, as soon as I do that, I now have 4 hydrogens. So to make 4 hydrogens on this side, I put a 2 out in front. So now I have a balanced equation. Here's another example of a decomposition reaction. So it says during a collision, a sudden flow of electricity is automatically sent into your airbag. So we're talking about airbags in your car. Electricity, we already said that's energy. Which is full of sodium azide, which is NaN3. This causes it to decompose into sodium powder and nitrogen gas. So it's an example of decomposition. So first thing I want to do is write out my equation. I have energy, and I have this cool powder inside my airbag, which is sodium azide. And what happens is when they react, I end up with sodium powder and nitrogen gas. All right, So I've written out my word equation. Now I have to write out my formula. Again, there's no formula for energy, so I just write down energy. They gave me the formula for this, so I don't have to figure it out. Formula's right there. It's NaN3. And it's a powder, so I know it's a solid. And that gives me sodium. The formula for sodium is Na. And it told me in the question it's sodium powder, so that means it's also a solid. And I get nitrogen gas out. Now nitrogen is a diatomic molecule, so I have to write down N2, and it's a gas, so put a little G for gas. So my last step is to balance this. Well, when I look here, there's a problem right off the bat. I have one sodium and one sodium. Then I have 3 nitrogens and 2 nitrogens. There's no whole number I can multiply this nitrogen by that's going to give me 3. You have to use whole numbers. So what I'm going to do is use kind of like the lowest common factor. I know if I multiply this by 2, I'll get 6. If I multiply this by 3, I'll also get 6. So I'm going to do exactly that. I'm going to put a 3 here and a 2 here. As soon as I do that, I realize, oh, now I have 2 sodiums, so I have to put a 2 here to give me 2 sodiums as well. Then we double check. 2 sodiums, 2 sodiums. I have 2 times 3 is 6 nitrogens. 3 times 2 is also 6 nitrogens, so it is balanced. So this is an example of decomposition reaction where I have one big thing and it breaks down into 2 smaller things.